Hey guys, Mr. Hyatt here. This is the last flip for Unit 1. You see on the screen there that we're going to talk electron configuration. I left that atomic structure stuff on there just because I want to try to bring things back to atomic structure as often as I can in this flip. So when we talk about the electron configuration, we're talking about essentially where are the electrons and how are they behaving. So configuration, think alignment, and then behavior. So you see there on the screen, each main energy level is divided into sublevels. So we'll have maybe an S part of the first orbital, then a P part of the first orbital, and so on. So each orbital can only hold up to 2 electrons. So if you look at this chart, you see that an S sublevel has 1 orbital and it's spherical. That's why it's called S. So for p orbitals, they're going to be perpendicular. They're on perpendicular axes. So that's this dumbbell shape. You see I'm kind of making it a figure 8. That's the path that the electron is going to follow. And then metals and lower level elements that are lower on the periodic table are going to have these D-shaped orbitals. And you can see that when we get these D-shaped orbitals, they're funky. That you can see the one I'm tracing with my mouse, it's cool shaped. It's not a sphere, it's not perpendicular, so it's not a figure 8. We've got a lot of electrons interacting, and that's really the key, is that the electrons are interacting, so that's making the behavior more sporadic. Where here we've just got a few electrons, they're not interfering, so one electron doesn't affect another one. Over here we've got just maybe 1 or 2 electrons, and they can stay far enough apart that they can buzz around in a sphere. By the time we get down to the F orbital, weird stuff is happening. And this is not something I would ask you to draw. Your college professors may expect that of you, but it's not something that I expect of you. So if we look at, let me move myself down over here out of the way. So due to main energy levels getting closer together, sublevels are going to overlap. This is really kind of beyond the scope of our course, but if you notice right here, there's some funkiness that happens between 4s and 3d. And we'll talk about why that happens and what that means on the periodic table in person. I want to make sure we have that conversation in person and I don't try to cover it through a flip. So I previewed a couple of things that we need to know. The first is the Aufbau principle there. It states that electrons fill orbitals of lower energy sublevels first. I talked about when you get on the bus, you take the first seat available. A packet that we did, Dr. Birdley talked about a movie theater. If you sit in the front, I don't know, maybe if you go in the back and you want to sit in the back, maybe that metaphor works a little bit better. But essentially the Aufbau principle is that they're going to take the lowest energy level first. So they're going to be as close to the nucleus as possible. And think about what that means in real life. It's a negative charge. If there's a negative charge over here, and there's a positive charge right here, that negative charge is going to be drawn to the positive charge. It's not going to stay over here, far away from it, just relatively close to it. It's a negative and a positive. They're going to attract one another, and they're going to be sharing that electron. They're going to be swapping that electron. We'll talk more about the abbreviated configurations. There are times that that's appropriate, and there are times that that's not appropriate. So we'll make sure that we cover those. I'll show you how to do them, and I'll talk about when you might want to use them and when you might not want to use them. When in doubt, just ask, and I'm more than happy to answer that question. Okay, so when we look at the orbital configurations, sort of the arrangement within the suborbitals, within the sublevels, 2 rules are going to determine their arrangement. So Hund's rule says that each orbital within a sublevel gets an electron before it gets 2. So once we start applying this to the periodic table, I think that will make a little bit more sense. Make sure you read up on Hund's rule. Make sure you know what that means in practice, or I'm sorry, in theory, and then we'll take care of what it means in practice in class and in person. And then the Pauli exclusion principle may be beyond you, may not. That is right at our sweet spot. So essentially it says that no 2 electrons in an orbital can have the same spin. Let me move myself out of the way here. So we've got up spins and down spins. This is probably new to your atomic structure knowledge. So electrons are, you can think of them as point particles, but they're also waves. So they spin and they rotate. So some electrons are going to just be, they're going to be skewed. They're going to spin this way. Sorry, I'm trying to figure out how to manipulate my hand in front of the camera. They're going to spin this way. Some are going to spin this way. What we found is electrons in the same orbital, one spins this way, the other one spins that way. They spin opposite directions of one another. And that's the Pauli exclusion principle. So that's really the basics of electron configuration. We need to be able to identify an element by its electron configuration. We need to be able to do the opposite. So we need to get an element and be able to provide the electron configuration. We need to be able to do the same thing for ions of an element. So think about how that electron configuration might change if you add an electron or you take an electron away. These are all ideas that wrap around electron configuration. If any of this doesn't make sense at this point, please come see me in class and we'll get you squared away. Thank you.